there, it's me again. I suppose I said I would have some kind of update to tell you about with that animated GIF thing. And, well, I managed to isolate the decompression thing. It was in here, and I moved it into common work. I'm anticipating maybe I'll add more decompression type things in the future, and this really only applies to pictures, but it's not under pictures. There is a new thing that I've added in here to do with pictures. I don't know if it really belongs with Windows. Maybe I should move that up. Yeah. Oh, no, it's in this project. The implementation for that is in the Windows. Well, there's not much implementation in that. Actually, there's no implementation. I can get rid of it. It's all in the header file. Indexed image or paletted image, however you want to call it. This takes us some dimensions, allocates some data, and has a set at X, Y value. I use a smart pointer for the data so that it's copyable, although that's not necessary. One thing I forgot is that these things have to be upside down if you want to write them out as bitmap. It's raining now, and I can't hear myself, but I assume the microphone's doing its magic. So I ran this pre-parse thing, which if I put in a -O switch, it outputs the images to BMP files. And I did that, and I didn't get the result I expected, although no, what am I doing here? Oh yeah. Let's see now. If output to file, and make a BMP file using standard palette. Palette either taken from the local palette or the global palette, depending on which one is supposed to be used at the time. If this exists, then I use the local, otherwise the global. The global palette is used for the first image, and the first image comes out perfect. See? Looks just like the real thing. In fact, I looked at it and examined it, and it's pretty much exactly correct. The next image looks like this. However, you'll notice if I change this back to horse, I changed the name of it to horse so I can remember. Okay, now the first image has been read in, and that's that one. It's perfect. Now I press a key. I have to press this twice. I don't know why. Now, this one has a graphic control extension, and so did the last one, by the way. I'm pretty sure it did. Yeah. Do not dispose. Okay. Now that I interpret that to mean that you're not supposed to get rid of that image. So it's a kind of a sequential building up of the one image on top of another. Now I don't know if these palette entries are the same, but I'm not sure how to draw the second image. If I should use, if I'm supposed to be merging them. And by the way, this is correct. B5 is index 181, and if you go and look at this image in the wonderful paint job program, which I don't know what's going on tonight, but I got about 100 updates. Index 181 is white. See, all these are transparent. You're not supposed to draw anything here. But see, now this here, where the legs used to be, right, is an image of the background. See? So this here is being overwritten with the gray background, so these legs would disappear. Nothing would get drawn here. This leg will appear. This leg will disappear. This leg will disappear. You see? So if this palette is the same as the other one, and they look the same, except one is bigger than the other, and that worries me. But maybe I don't know why the palettes are not the same size. But maybe I just start off with this palette, overwrite this palette with this palette, okay, with the one transparent part. I don't know, it's unclear how to draw it. If I did it in if I converted these to non-palettes, I suppose it's easy to draw. But then I still need to know which index it is. Not draw these parts of this image. And I gotta fill it. All this is doing is filling in the background. It's crazy because if you look at that, the output's still there. I don't know why they do it this way. Okay, that's 10K for that image, which is all that does is fix up a few pixels. And the first image, 13K, and the next one's, but they're all about the same size. So what's the point? There's no advantage to, doing it progressively like this that I can see. It's still the same amount of data. Although, in terms of drawing it, there's less drawing to do. So transmission speed is not improved, but drawing speed is, like we really care. So yeah, so then you get that, and the images you can see it's going through the sequence and everything, and the transparent color, just a test here, read my colors backwards. If I could do the sequential merging, right? And all of these are supposed to be retained. Everything is supposed to be retained as you go along. So things erase themselves, right? The splotches of gray indicate where things are getting erased, and that background is reappearing, right? So what can I say? It's the data is perfect. It's just a matter of a lot of thinking and trying to figure out how to do that merging. But it's not so bad because the problem is isolated. You see, because I've got this, I put where did I put that thing on? Where did I put that picture thing? Image, TS image. Okay, now see, this is the thing that it's a paletted image, right? And they can be passed around. That's might be handy now, because what I want to do is hang on to them and merge them, like create a list of these things. Maybe make a list, like a regular linked list of these images. Then when it comes time to draw output the next picture, I can walk through the list and draw the first image, and then draw the second image, and so on. However, they all have an associated palette. The palette's not written in here. But I could put, another one of these I could add that to this data, right? These are the indices. I could add a palette to the data as well. And do it that way. It's just weird that I don't know why the palette gets smaller. 194. Okay, that's image 3. Is this thing still running? I'm not writing out the image number. Yeah, that was the first one. No, it wasn't. B5. Okay. Next one. Its transparent index is C2, which is 194. I think I remember. Gee, 194. So you see, that's all it is. It's not a trivial draw. You can even see the picture of the background here, see? Right? It's, I don't know, maybe they did it this way as an exercise to, for people to learn how to do a sequential draw, like an incremental draw, because in terms of size of data, there's no improvement. Oh, that's not true actually. These are the decompressed ones. No, but even the compressed ones were not, it didn't go down that much. Anyway, so that works. That's a completely solved problem, except for the fact that I have to write more code if I really want to generate that sequence. And that's not very difficult, but it's one of those painful things. Yet another painful thing. But well, what else did I add? I added a bunch of kind of funny things. Have you ever thought of my unit test program? You ever thought of this problem? I added split path. We got that finally. So now we can. Suppose you have a number right here, pi, which I have to find somewhere. Okay, and I want to round to the the eighth decimal point or something. So one of the functions I have is d round, which takes a double d, and precision, let's say 9 decimal points. Okay. Now the question is, or my question to you is, what's the algorithm for rounding, given what I have there? Start up. Okay, now you'll probably accept that this looks like the correct answer, right? I mean, the same, except the 3 becomes a 4. Now, pi is not the only one I have in there. Log days. Okay, now see here's one. You're going to see all over the place people write this function called round. Round, int, round, double, right? And it's always the same. It's suppose d is positive. They would say int d plus 0.5, right? Okay, or it's minus d less than 0. Something like that. Something like this, right? And it's my contention, that is not the correct answer. That does not generally give you the correct answer. If you believe that this number is the answer to that last rounding was correct, then you should disagree with that, adding 0.5, right? Because if sorry, I'm going to change I want to change my wording on that. Here's the way I would word it. If you believe, last time I said it, if you believe that the last result was correct, then you should think that this is wrong. We can compile. I'm sure it's not wrong. Oh. If, what I would say instead is, if you believe that this is the correct way to round a double to the nearest end, then you should not believe that this is the correct method to round a double to the nearest end. That's what I would say. You can't believe that this algorithm is correct without immediately following that it must be incorrect. And that's a bit of a puzzle. And I'm going to just leave you with that as a puzzle. Why is this wrong? I mean, it could be right. No, it can't be right. If it was right, then it has to, by definition, be wrong. And that's my puzzle. Okay.